Can you please allow permission to share the screen?
Now it is okay, sir.
It says host disabled participant screen sharing. Or else you should change me also as a host so that I can share my screen, it says.
Sir, is it okay now, sir?
Yeah, I think yes. Okay. You can see the presentation, right? The screen is visible now?
Yes, sir. Yes, sir.
Oh, great. Okay. So, once again, good afternoon to all. At the moment, I can see 21 participants, except the internal participants, there may be 10 to 15 participants at the moment. It's just after the lunch time, and listening to machine learning after lunch is not going to be really nice. That's my personal feeling. So I will try to make this session more and more interactive. So I have a set of questions for which I expect your responses, so that we will have a better interaction throughout the session. And you can stop me at any point and ask me anything. But however, I will ask you a few questions here and there, very general questions, and I need your response in the chat box. I expect you to either by unmute your mic and give me the answer, or better, you can put your answers in the chat box. So I prefer receiving answers in the chat box so that we can easily view the answers of others and the understanding of others in that sense. I hope you all agree with that. And I will just move on with my presentation of today. So my topic is learning automata for engineering applications. I will talk about how we are using learning automata for engineering applications. But uh, I would like to say thanks to my mentor, Professor Imtiaz Ahmed, for teaching me what is learning automata. I'm here to talk about learning automata only because of him, because he is the one who taught me what is learning automata with the fundamentals of the probability and little mathematics about it. So I applied that learning automata to solve one of the problem, uh, which is the core contribution in my thesis also. My PhD thesis I was able to complete with the help of introducing a novel approach using or adapting learning automata. That is what we are going to see today also. So a brief introduction about our university. Presently, we are holding 44th rank worldwide, and we are listed in the top 150 universities in Asia, and we have ranked with rank 126 from 2022. And we just entered the 2023 ranking recently, and we are awaiting the results because the ranking is in process at the moment. Regarding to academics, in our university, we have 5 schools, which are School of Business, School of Computing and Informatics, School of Applied Sciences and Mathematics, Faculty of Engineering, and School of Design. and I belongs to Faculty of Engineering under Electrical and Electronics Engineering program area, where we have Master of Science by coursework in Electrical and Electronics Engineering and PhD MSc by Research in Electrical and Electronics Engineering and also PhD in Electrical and Electronics Engineering. Of course, we have undergraduate degree, but the intention or the reason behind showing only the master programs and PhD is that any international student can enroll for a master program by applying for scholarship through Ministry of Foreign Affairs, which opens in every February, and the intake will happen in August intake. And for PhD in Electrical and Electronics Engineering, again, we have scholarship, local scholarship from the from the university itself. So, but it is a bit competitive because at the moment we are offering only 5 scholarship per year for PhD for the whole, I mean, which is applicable for the whole university. However, if the candidates are competitive, then university is ready to offer more than one PhD to one school and particularly to one department itself. For that, you need to go along with the proposal. A detailed proposal need to be submitted and an application need to be filled by the time in there is a call for PhD applications. So, as I mentioned before, I would like to talk about artificial intelligence and machine learning, just to give an overview, general overview about what is machine learning and what is artificial intelligence in general. Then we will move on to the topic which I really want to talk about today. So, if you have any general, as I mentioned, if you know or if you have any general answers, you can unmute your mic and give your perception on what is your understanding about artificial intelligence or machine learning, or you can type some answers in the chat box. So I will wait for say 1 minute to receive some responses in the chat box to know what do you understand about artificial intelligence and machine learning. Any responses on this? Nice. So the lunch really makes you feel better at the moment, I can see. As I mentioned at the beginning of the session, sitting for a session after the lunch is something really wonderful. And if you're sitting in the air-conditioned room, then things will be more nice. Let me quickly have a look around few things, at least, yeah. So before getting into the understanding of, can you at least answer for this very basic or fundamental question? What are the basic needs for life? At least can I have some answers for this one? What are the basic needs for life? We generally used to say that there are 4 basic needs for life. Can you give some answers in the chat box, please? I am eagerly waiting to see some answers. What are the basic needs for life? Thank you, Ms. Priya. Thank you for your answer, and I hope everyone will agree with that. Food, shelter, water, and clothes. So this is what we call as basic needs for anyone's life. And this, like in recent times, that has literally changed a lot. Can you prioritize something else which is more important for you other than this food, shelter, water, and clothes? Anyone? Is there anything, do we feel or do we think that this is also a basic need or essential need in day-to-day life? Anything as your priority? I told you this is not really a technical question. We have our own perception, right? Or we have our own understanding on what is more important for us in our life or for our day-to-day activity. So other than this food, shelter, like I have the same answers here. If you have a look at this slide, this is what I have. It is food, of course, And if you go and search for food in Google, for example, you will not get the traditional food or local food which is served, but you will find only this, what to say, the burger or pizza as a food in the Google image. So just to keep it really local, I found another one, which is appam, kadal curry, and this coconut milk, right? And shelter and clothes. But that is what I said. But is it sufficient now as per our day-to-day activity or based on the lifestyle we are living? What do you think which is again still essential or without which we cannot just handle a day? Is there anything else? See, this will be very difficult if you don't respond, as we have only 15, I think, right? Yeah. How many? Yeah, 25 participants at the moment. And if we don't get any responses, this will be difficult. Anything as you feel, peace, internet, then anything else, please? Please, more answers. Thank you. Thank you for those who responded. Anything else? Health? Yeah. Then mobile phone? Very good. Then, so if you want to talk about health and peace, you need, like more deep thinking. Then only we can come to the conclusion that the essential for life is more importantly health and peace, of course. But I agree with the other two answers, and like life has changed a lot, right? And mobile phone has become one of the another essential or basic need for life. Like we can stay without someone who is more important in our life for a day, but we cannot imagine having a day without mobile phone, right? And exactly the other one is internet. So I just took Wi-Fi as a figure here. However, as I mentioned before, it is changing. I mean, things are changing time to time based on our priority, and that priority brought something else into our life where we have mobile phone with more and more apps and the internet connection, which also become basic and essential part of our day-to-day life. Thank you for your responses. And this picture really disturbed me a lot. Not just disturbed me a lot, this picture says a lot, actually. If you have a look at this picture, there are two messages. Humans are hooked and machines are learning. Have a look at the figure. This is what we are doing. I'm not generalizing, but most of us are doing in our day-to-day life, right? We are all busy with our gadgets, not just the mobile phone. We are most of the time, most part of our day is engaged with the gadgets and very particularly with the mobile phones. As much as we are spending our time with our mobile phone with internet connection and we are into the internet, because if you are using a primitive mobile phone with the switches and all, that's not going to help the machine to do anything. But as long as we are engaged with the machines in general, the machines are learning a lot from us. That's the point, actually. So what is artificial intelligence? A definition for artificial intelligence is that it is an area of computer science that emphasizes the creation of intelligent machines that work and react like human. So we are creating intelligence artificially. So the machine which has artificial intelligence should obviously react or behave like a human being, right? Because we are just mimicking or recreating the intelligence of a human being with the help of the machines. So the machines are expected to work or behave like humans. So what these machines can do? Some of the activities computers with artificial intelligence are designed for what? These are some simple examples. right? Whatever you have seen here, the artificial intelligence machines are used for speech recognition, learning, planning, and problem solving. The definition for machine learning. Then I will just talk about the definition for machine learning. Then we will see more and more interesting factors how machine learning is playing a role in our day-to-day life. It's an artificial intelligence which provides any system to automatically learn and improve from experience without being explicitly programmed. So every sentence or every statement makes a real good sense here. Machine learning is a method of artificial intelligence which is allowing the system to learn automatically from the experience. So machine learning is all about learn from experience. If you want to make it in a single straight statement, machine learning is an approach to learn which learn from experience. So it focuses on the development of programs that can access data. That is very important, right? The most important part lies here, that can access data and use it to learn for themselves. Excuse me. Hold on for a second. I just got an important call. I'll get connected to you soon. Okay, really sorry about that. My apologies. It's just an important call which I cannot really miss. So we talked about machine learning. Now machine learning focus on the development of computer programs that access data. I reiterate, I underline it, access data and use it to learn for themselves. That is the most important part about machine learning. So the process of this learning begins with observation of data, which can be from the examples or from direct experience, or it can be a sort of instructions from where the machine learns or collect information. Then, in order to look for patterns in data and make better decision so this is how machine learning works. What machine learning do? Machine learning collect all the relevant informations which it require to learn the process. And whenever a similar situation occurs, then it take decisions based on the learning process it attained before. So the primary aim is to allow the computers to learn automatically without human intervention or assistance and adjust actions accordingly. It do everything by yourself without any intervention from the human being. Let's see how this is happening here. So in a very large extent, when we talk about machine learning can be further classified into three different categories. They are supervised learning, unsupervised learning, and reinforcement learning. And we will focus, like here, this is supervised learning, where we talked about something, then unsupervised learning and reinforcement learning. Under this reinforcement learning, now we are going to look after this real-time decisions and artificial intelligence game. These are the something which we will further narrow down. We are not going to talk about all these things. I am not going to talk about all these things. I will just go with some sort of real-time decisions, how a machine read and behave based on reinforcement learning. Again, some of the key terminologies associated to machine learning are optimization. With the help of machine learning, you can optimize, you can predict, we can forecast, or we can classify. And with the help of the machine learning tool, we can take decisions. Actually, a machine learning tool can be used as a decision-making tool. Yeah, the machine learning terminologies can be used as a decision-making tool. And that is one such thing we did, or I did in my work, that we will see in the forthcoming slides. So I have another question now. How often we use internet and what is the purpose? So can I have some answers? How often we use internet on an average? How many hours we use internet in a day? In my case, like I will say that I am using internet on an average of 10 hours a day. Sometimes more than that, but on an average, I use internet for 10 hours a day. Yeah, 8 hours. She's doing PhD. So she is using quite a lot. Yeah, 8 hours. Farsana has poor internet connection, it seems. So this is the thing. Our internet usage vary between, on a standard of 6 to 12 hours. We use internet for several purposes on an average of 6 to 12 hours. So those who are using only 2 hours are really with good health and mental peace. It's because the more we are into the internet, the less we are with mental peace. To some extent, that is also acceptable fact. Now, I would like to have answer for my second question. For what purpose we are using internet? You can name the app or the applications or the media which you are using. For example, if you are using to use WhatsApp or YouTube, Google search, Instagram, Facebook, whatever. Can you please give some reply or response for what purpose you are mostly using internet? Then it's very surprising to know that nobody is using Facebook or Instagram, isn't it? Those who are attending the class today, none of you are using Facebook or Instagram, Twitter, nothing. Shall I have a few more responses? So it's mostly revolving around some common factors, and the most common factors are, one of the most common factor is WhatsApp, because WhatsApp has become another essential part which we use mainly for personal communication, because WhatsApp made communications really simple, fast, easy, and direct. So we are using WhatsApp mainly for, excuse me, mainly for something like official communication also, because every official communication is now happening through WhatsApp. Other than that, we used to do some Google search, then we watch videos for several purposes, for entertaining videos or whatever, or education videos or research purposes. We use YouTube mostly. Then we spend time on Facebook, Instagram, Telegram, etc., etc., etc. So this is how our data is being used, right? And how so this is the thing. And now we have got some answers how our data is being used or what purpose we are using internet. Let's go and explore further what is there and why did I ask this question. So do you have any can you give me some examples where we are using really machine learning? Anyone, anything? Do you have idea about where this machine learning is applied? Any examples? Some answers again. Who is using or where machine learning is used? Or among the app or the social media pages which you are using, are they really using this one, Instagram? Then ChatGPT is a more advanced machine learning technique, of course. So because ChatGPT is a typical example for machine learning, since the data, I mean, the machine is trained with a set of data, but we know I mean, I was about to talk about that, but ChatGPT had a big boom in the last uh, uh, 3-4 weeks. Again, it had some flaws because of the limited resources available with the ChatGPT, because it had only information for training until 2021. Let it be. So I will show you some examples which are using machine learning. Google is one of the best example for machine learning, where machine learning is effectively used is Google. And you can go and read more about how machine learning is used in Google from this page. And this is another important factor. You might have noticed several times. I mean, if you are using regularly YouTube, then whenever you open YouTube, automatically YouTube feed you something in, right? This is my page, for example. This is a page I have taken, like if you have a look at my page, few things are very common, because I have been quite recently, I have been watching some videos on yeah, I have been watching few number of videos on this drives and control and electrical machines. I am teaching at the moment. I am teaching electrical machines, and I want to collect some information. So I was watching these videos, and I regularly watch news in these pages, which you are seeing here. And of course, yes, I am working on electric vehicle research, and I have been watching some videos on modeling and simulation of electric vehicles using machine learning. Then this is showing one movie review, which I really don't follow, but still it is appearing here because I used to watch movie reviews in another channels. So, and this one, the one which you are seeing here, that is also not the one which I regularly watch. So, according to this page, the eight recommendations which are coming here, I do watch this. I do watch this channel, and I watch videos related to this one. I watch this channel for news. Then I am not quite sure about this one, and This one is basic concept. Of course, I watched some videos on stepper motor, but not really in Hindi anyway. Let it be. But the concept is here. I mean, what I'm bringing into is, it is giving me recommendations based on what I have been regularly watching in YouTube. At the same time, it brings me something random, right? I told you that I used to watch movie reviews in some other channel, but here it is giving me an option to go to something else. This is a random option or random feed by YouTube based on my searches. Then again, this one, the page which you see here, I had never been to this page, or I had never searched for anything related to this one even, but still it is giving me some random search result. There may be some keywords might be related to this one. So this is one such example, what is recommended to you by YouTube. And another interesting factor, what do you see in your Amazon page when you logged in? What it is saying? Recommended for you, Sheikh. I didn't ask for recommendation seriously to Amazon, but Amazon is ready to recommend me something. If you have a look at this, yes, I have been searching for some good shoes for a while, but this page is a bit old. This is not the recent page which I have taken. YouTube is my recent page, but the one which you are seeing here is quite a long time ago. I was looking for, I was planning to buy a Honor phone, and I was searching for the phone. And now automatically Amazon is recommending me something to buy, which is related to my past searches. Let it be. Let's go and see something more on it. So, how the machine collects our data is a question. Do you have any idea how the machine collects our data? So, of course, it is collecting our data from our Facebook page, Instagram page, our Google Map timeline, Google searches, and any other social media pages which you are using. But who gave permissions to collect data? How it is collecting our data? Do you have any idea? Who has given permission to collect our data? Any responses? Who has given permission to collect the data? Because machines are collecting, like I said, yes, I said that the machine collect the data, and based on the collection of data only, the machine is feeding you next time when you are opening the same machine, or when you are getting into your account again. But of course, who gave permission? It's only us. And where and how we are giving permissions for that? This is one typical example meme which I recently got. So here, if you, it says everything. See, when you say something, when you say that you want to buy something, who is sneaking at your door? It's all your social media pages. And when you are really getting into it, who is coming into you, or who is showing more interest on that? It is all these pages. So I totally agree with the response given by Hani, that we are giving permission to access each and every data belongs to us by just clicking agree to the terms and conditions. And in recent times, like if you have a habit of just clicking on allow cookies, how many of you do that? In recent times, whenever you open a page, you open a new page, or when you are entering into a new website, it asks your permission to allow cookies, right? Isn't it? So, how many of you let it simply to accept cookies? You can type Y here if you do so, without reading what is there and without checking what are the recommendations. So I expect your response, not accepting. Okay. Then is there anyone who directly accept the cookies? Why? Yes? Anyone else? If you are directly accepting the cookies, don't do it next time. That is my one personal suggestion to you, because there are more options to select cookies. Go and select only to use necessary functional cookies. When you open that page, it will show you performance cookies and other cookies there. Don't allow them because it will collect all your information. Right. Whenever we are allowing cookies, this by allowing or by simply accepting to take cookies, you are allowing that particular web page to collect all your information which you are using to surf across the internet for several purposes. They say that they are using this for marketing and improvement purposes. So whenever there is a cookies, you either reject all cookies, or if it is not allowing to access the page, when you reject all cookies, accept only cookies which are mandatory or functional. Okay. So this is what technically happening when we really go and search for something in the internet. This is what happened. Every social media page, because we have app in our mobile phone for everything, right? All the apps are there, and they always collect information based on your day-to-day activity or whatever you search or surf in the internet. And this is giving you the recommendations based on that. Let it be. So this is a brief introduction about machine learning, or how machine learning works, because we need to relate that machine learning with learning automata. Learning automata is a tool which is a part of machine learning algorithm. So I just thought I'll give a brief introduction about what is machine learning. So technically, machine learning, one key mantra which you need to understand about machine learning is machines learn from the experience. So machines collect information and learn from the experience. The more and more you search, or more and more information you feed on, the more and more the machine will learn, and it is learning everything from us, right? Whatever the machine is giving back, the machine learned everything from us. Learning automaton is an adaptive decision-making unit situated in a random environment that learns the optimal action through repeated interactions with its environment. I will read it again. A learning automaton is an adaptive decision-making unit situated in a random environment that learns the optimal action through repeated interactions with its environment. So the actions are chosen according to a specific probability distribution, which is updated based on the environment response the automaton updates by performing a particular action. You understand everything about learning automata by now, by reading these two? It's going to be interesting. That is what I am trying to say, because at the moment, I'm quite sure that if you read for 4, 5, 6 times, maybe you will get crux of what is learning automata. But through a concept, we can easily understand what is learning automata, and learning automata is really interesting. I will repeat the same definition sometimes later. Before that, I would like to discuss these things now. We will discuss a little mathematics, where we will talk about probability mean and probability density function. Then I will talk a little bit more about the gambling games, which are fortune wheel and slot machine. Further, I will move on to Enna Bandit problem, which is the core idea behind learning automata, which is giving pathway to establish learning automata. And I will explain the example or application which I developed with the help of this learning automata. So there is nothing much to go into deep for the probability. As we know, probability is a measure of likelihood that an event will occur. Whenever we talk about probability, two things we talk in probability are about a dice, throwing a dice, and tossing a coin. So probability is quantified as a number between 0 and 1, where 0 indicates impossibility and 1 indicates certainty. Let's have a look at some examples. What is impossible and unlikely? So these are all what I said. Here, there are 1 in 6 chances. So the probability of throwing a dice or getting a particular number from a dice is 1/6. And the even chances are where we have a coin to toss. The chances are even, which means 1/2. And likely, the probability of getting a red color ball from this group, the probability of getting a red color ball from this group is 4 in 5 chance. Then what is impossible or what is certain? Impossible is that, like the typical example is that sun will never rise from the west, or what is certain? Sun always rise, right? This is another typical example for a probability. Let it be. So rolling 7 in a dice is not at all possible, and sun will rise for sure. Then what is mean? Mean is the average of the numbers, where a typical simple example is that between 0 to 12, the mean is 6. So when you are, the beauty of MATLAB is that MATLAB works with equal probability distribution actually. So when you are typing or when you are trying to get a mean value between 0 to 12 in MATLAB, if you type it, it automatically give you 6. That is based on the command. So the mean between 0 to 100 is 50 again, which can be taken in other way around. I have given some examples which I have taken only from MATLAB. I will just read out this program, a very short program which I have written in order to find the probability of tossing a coin. Right, because when I started learning, learning automata, I just would like to share this story now. I explained my problem actually, what I am planning to do in my PhD to Professor Imtiaz. And he asked me to deliver a presentation on my actual problem, where I am trying to find a gap in order to establish something. So I did my PhD on maximum power point tracking algorithms for solar PV system. Then I delivered a presentation to him one day. After seeing my presentation, he said, yes, Sheikh, we can really implement, or we can use learning automata to develop an MBPT algorithm. So I was happy about that. I said, okay, now I am going to start working on learning automata. Then he said that for the next few weeks, I will give you some task for you to develop some codes so that we can enter into learning automata and reinforcement learning algorithms. I initially started with reinforcement learning, but I will tell you what happened. So I was all set. Then I said to myself that, okay, I'm going to now learning automata and I'm going to write program. That's all great. When I went to meet him for the next time, during our meeting, when we decided that I am going to work on learning automata to develop my MPPT, this is the first program he asked me to write actually. He asked me to write a program to find the probability of tossing a coin. Then I said, what? You told me that I didn't say a word to him. I went to my office and I was wondering. He told me that he's going to teach me learning automata, but he asked me to write a code to find the probability of tossing coin, and I didn't understand on that day why did he ask me to do that. but there is a reason behind it that I will also share with you sometimes later. So this is the first program I wrote as a part of my learning process of learning automata. So this is the first task assigned to me by my mentor. So the program is very simple. If you have a look at this one, I have assigned something to enter the input for number of trials. So those who are familiar with Python, C programming or MATLAB obviously can easily understand this one. So the number of trials, then I initialize H stands for head equal to 0 and T stands for, tail also equal to 0. So for I is equal to 1 is to n, that depends on the number of trials which I am going to select. The result will be biased function of I. I will show the function which I have written again. So if the result is equal to 0, then it will increase tail by 1. If the result is not equal to 0, then it will increase head by 1. So at the end, when the loop is over, it will give the answer for H and T. So if I am giving, for example, if I am giving n is equal to 1000, it will show the results as number of times of head and number of times of tail. This is the function, right? So as I mentioned before, or as we just discussed now, the probability of getting coin, the probability of getting a particular side on the coin, either it's a head or tail, is 1/2, right? So I have selected a probability of 0.5. I have selected a probability of 0.5. And I told you before that MATLAB works with equal random probability. So when you are writing random of 1, it will take a number between 0 to 1. And if you do it for 1000 times, then the numbers will be actually equally distributed. If you do random of 1 for 1000 times, when you analyze the results which you are obtaining from MATLAB, these numbers which you are going to obtain will be 500 numbers among those 1000 will be less than or equal to 5, and remaining 1500 will be more than uh, 0.5, between 0.5 to 1. That is how this rand command work in MATLAB. So what did I say here? If x less than p, then it will take number equal to 0. If else, number equal to 1. So this p, I am comparing with random number. I am comparing p with a random number. So every time it produces a number, it can be between 0 to 1. And if the number is less than 0.5, I will count it as 0. When it is 0, I consider this as tail. If it is more than 0.5, then I consider this as 1. When it is 1, then I am counting head is equal to 1. That is how this program is written. Now I have given 1000 trials, and if you have a look at the answer, since this coin has an equal probability, so in 1000 times, I got 495 times head and 505 times tail. So what is biased coin? In some cases, like we always used to have a say that some coin, when we toss a coin, we used to say that this coin mostly give head or this coin mostly give tail, right? So that coin is biased coin. The coin which give results beyond the probability is probability is 1/2. If it is working against the probability, then that is what we call as biased coin. So the coin for which the probability is not 1/2 is called a biased or unfair coin. So I have taken another two examples where I consider that the coin can give mostly tail, or the other example is the coin can give mostly head. So if you have a look at this again, the biased coin, the one which I have taken here, what it is doing, when they are doing the same 1000 number of trials, head is 214 times and tail is 786 times. So more number of tail. On the other hand, for the same number of 1000 trials, Now head is 808 times and tail is 192 times. So what I did here, so I just adjusted my probability. Actually, I just adjusted my probability which I used in this value here. If you change the probability to 0.2 or 0.8, it will either work at one of the side, because that is the way how this randomly equally distribute the random values. So what is the probability of getting 1 from a dice? What is the probability of getting 1 from a dice? Can you just type your answer here in the chat box? The dice has 6 sides. So what is the probability of getting 1 from a dice? Can you put your answer? The probability of getting number 1 in a dice, from a dice. What happened? Everyone is sleeping or what? No answer? So the answer is 1 by 6. What is the probability of getting number 2 from a dice again? What is the probability of getting 2 from a dice? It is again 1 by 6. So probability of getting 1 from a dice is 1 by 6. Again, for 2 it is 1 by 6. And for 3, 4, 5 and 6, it's all 1 by 6. Therefore, the probability density function, which is called PDF in short, of a dice is uniform, right? So the probability of a dice is uniform, and the uniform probability density function of a dice can be written as 1 over 6 for 6 times. 1 over 6, this is for 1, 2, 3, 4, 5 and 6. So this is 1 over 6 for 6 times. What will be the probability density function for tossing a coin then? It is the same. Uniform probability density function of a coin is 1 over 2. So I have brought 2 examples here. One is that it will be 1 if x elements of 0, 1, otherwise it will be 0. And the other one is here. Can you tell me what is the answer this will give? The second one, let us forget about first one. What will be the actual, actually, if we are going to put this one on this plane, how it will looks like? I mean, what will be your final result? If you have a look at this one, let me try to connect my. What will be the nature of the waveform which you will obtain with the help of this function? Can anyone say? So if you have a look at this one, between 0 to 1, whatever the value you give for x will be as such. So when it is 0, it will be 0. Let me put some values here, 1, 2, and so on. So when you are trying to give some values, the value, if it is between 0 to 1, whatever the value you are taking will be x. So if it is 0.5, then this is going to be, the function is also going to be 0.5. So I will say that this is 0.25, 0.5, and let's say that this is 1. So when in between this value, whatever the value you take, if you take x is equal to 0.5, then the function of x is also 0.5. And when x is equal to 1 or x less than 1, then it is here. So when you put some values here again, when you are coming for between 1 to 2, the value will be 2 minus x. So for example, if x is equal to 0.1, then this is going to be 0.1. If it is 0.25, this will be 0.25. If it is 0.5, then this will be 0.5. If it is 0.9, then it will be 0.9. And when it is coming here for 1, so let's say this is 1 and this is 1. When it is more than 1, in between 1 and 2, let me say this is 1.25. When x is 1.25, this will be 2 minus 1.25, which is 0.75. When it is 1.5, this will be 0.5. When it is 1.75, this will be 0.25. And when it is 2, this will be 0. So when you are putting these values, this will technically, like, let me put 1 here. And this is 1 here. So this will technically make a triangle. I will consider this as 1 since I draw this one. So you can put all our values which you have just calculated here. It will give you a triangular function here. So these are some small examples for the PDF. Let it be there. Let me move on further. We will see actually the concept of fortune wheel is more and more important because this will help us to understand learning automata in a much better way. So this is what we need to know. Like this fortune wheel is being one of the very famous game. So if you have a look at this one, they all look similar, right? They all look very similar. But if you have a close look at the numbers which are presented here, you will find the probability of getting 2001 here. Can you count how many number of 2000 are there? If you have a look at it, see, there is only one 2000 in the whole fortune wheel. And there are more number of ones, 1, 2, 3, 4, 5, 6, 7, 8. And the other numbers are smaller numbers. That is one thing. Let it be there. It is not just over here. You have to look at the thickness of the color shade. If you have a look at the thickness of the color shades of lower or small numbers, they are big. But the thickness of the color shades of bigger rewards or larger rewards are very thin. It's not over here. Another important thing what we need to realize is that if you have a look at this, beside every or at both sides of every larger rewards, what do you have? The smallest reward is just beside that. Have a look at it. 50 is already very thin, but just beside 50, what do you have? You have 1 at both sides. Then a very large shade of 2 and 3 are there. Come to second one now again. It is 20 here. 20 is in between 2 ones, and also the other 2 rewards are 2 and 3, the smallest rewards. Come to 2000 again. In 2000 also, the thickness of the shade is very small. Again, the smallest rewards are beside that. Again, if you see, the next to them are 2 and 3. Even if you miss them, you may get 5 or 8. Let it be there. Come again here, the same story. So this is how This is the probability actually. So according to this wheel, if you have a look at this one, which one has more probability? Have a look at, that is why I mentioned here, have a close look at the fortune wheel and find the probability of getting 2000. You need to count all the numbers actually, right? It is 3, 6, 8, right? 2, 4, 5. So 5 plus 5 plus 5, 5 plus 5. 20, 23, 26, 29, 32. So the probability of getting 2000 is 1 over 32, right? The probability of getting 2000 is 1 over 32. Again, the probability of getting 20 is 2 over 32. Probability of getting 50 is 1 over 32. But at the same time, probability of getting 1 is 8 over 32, right? Which one has more probability now? The smallest rewards, not only that one, there are other numbers. 3s are there, 2s are there, 4s and 5s are there, right? All those numbers are having in every section you got more than 1, 2 or 3. So in any gambling game, so ultimately what I'm trying to say here is, in any gambling game, the possibility of receiving the best reward is always very less. So this is a slot machine, which is very famous in gambling casinos, where the machine has 3 or more wheels. This is what we see, like mostly we can see them in English movies, where what happens whenever, this is also called one-armed bandit. This is also called one-armed bandit. So what happens? The machine works in this way. When you place a coin, and once you place a coin once, you can operate this lever again once. So this lever will make this slot machine to run, and it will bring something random. So every time, let me go on further to see what will happen here. Every time when you put a coin and push the arm once, it will provide or produce one random reward. It will provide one random reward. So you play one coin, you play the arm once, it will give you one reward. And when you play the same thing again next time, it may not give the same reward. That's why I said every time it will give you a random reward. So what is N-arm bandit? N-arm bandit is a slot machine with n number of amps. A slot with machine with n number of amps. Each arm will give you a random reward when played. Each arm has a set of reward and a PDF. So I already explained you what is PDF. We will see in a more intellectual way how this is working. So here, how this works. A player can play any one of the n arms. There are n number of arms in this machine. By paying $1, for example, when you pay $1, you are allowed to play one arm among the n number of arms. When you play one arm, this arm will give you one reward, and that reward will be random. So consider that, like we don't know what is the reward available in any of the arms. We really don't know what is the arm available. Sorry, what is the reward available in the arms. Let us consider that one arm. I have shown you several arms here. I will consider that arm 1 has these many rewards. Reward is 0.60 cents, 0.70 cents, $0.6, $0.7, $0.8, $0.9. Again, it is one actually, $1, $1.1 or $1.2 is the reward. So the PDF is assumed to be uniform. What is PDF is assumed to be uniform? The probability of getting this is 1, 2, 3, 4, 5, 6, 7. So the probability is 1/7 for all of them. When a player plays an arm, the slot machine will give a random reward corresponding to the arm played. Again, I am repeating, I am going to play arm 1. I am going to play arm 1, which is having this set of rewards. When I play the arm once, this will give one reward. When I play arm 1, this will give one among these rewards. But it can be a random reward. It is not necessary that first time when you play, it will give 0.6. Second time when you play, it will give 0.7. Not like that. It will give one reward, which will be random among this one. So every time when you play the arm, every time when you play the arm, you will get one reward. That reward will be random, and it is not necessary that reward remain same or in order. So what is the case here? When a player plays an arm, the slot machine will give a random reward corresponding to the arm played. That is what I explained. If the player plays the same arm again, he will not receive the same reward again. He may receive, but it is not certain that he will receive the same reward again. It will give another reward from the available rewards. Now let us say that the arm played by the player is A. Then the random reward received by the player for playing arm is O of A. So the player plays an arm A and he gets a reward of O of A. See, the reward of arm 1 is between 0.6 and $1.2. I said already. So what is the mean? The mean of the arm is $0.9. So the expected value of reward for arm 1 is denoted by Q of arm 1, which is 0.9. So the expected value of reward is nothing but the mean of the arm. So the arm has these values, and when you play the arm, you will get a reward of such value. So we can say that each arm in the machine has a random reward between xi and yi, and the mean is qi. That I am explaining with the help of this figure, this table. Now consider that we have a 5-arm slot machine, and the machine has, each arm has this number of 7 rewards. Each arm has 7 rewards. What you see here is the mean of these arms. From the first observation, we can say that the highest value is 145, the next nearest value is 125, but the highest among the lowest value is 75. So, for example, when a player plays an arm, and if he received the reward of 145, and if he received a reward of 145, what will happen? What he will obviously think as a player, as a gambler, what he will think? This arm is going to be the best arm. But is it really true? That is what we are going to analyze with the help of this example. So we will do a little mathematics on this one in order to understand further what is this doing. Each arm gives a reward for every play. Whenever you play an arm, the arm will give you one reward. OA is the reward received by the player for playing arm A in ith trail. The actual mean of arm A is given by Q of A. For example, in this case, let me go back to this table. So this is arm. The mean of this arm is 95, and the expected reward of this arm is again 95. Expected reward of this arm is 90. Expected reward of each arm is given and highlighted in this table, which means mean of the table is the expected value of the arm. Let it be. So every time when you play, the actual number of actual mean of arm is divided by Q of A, and the estimated mean of A for n number of trials can be, it's a very straightforward equation. You are playing the arm for n number of times. Every time you play, it will give you one reward. You are just taking the mean of the rewards. The rewards are random. So if you are playing the arm for 1,000 times, then you are getting 1,000 rewards. You are adding all the rewards and divide it by 1,000. That will give you the number. So it's a very straightforward equation. Now let us consider n is equal to 10. I played one arm, which is arm 1, and I got the reward. Randomly, I got rewards which are listed here. So according to these numbers, if you add them and find the average or mean of these values, the expected mean of playing one arm, particular arm, which is having a random rewards, which we discussed at the beginning, this is what you are going to get. So we can estimate the mean of all arms by playing each and every arm for n number of times, isn't it? So if you want to find, because here I said that I know the mean value here, but if you really want to find, it is not known to us what is there in each arm. So if you want to find the mean of each arm, what do you need to do? You need to play each arm several number of times. That several number of times is what I meant by n. So for example, we have 5 arms, and if you want to, let's say that you are playing every arm for 10 times, for example, or 100 times, for example, to find the mean. What you will do, you will play arm 1 for 100 times, arm 2 for 100 times, arm 3, 4, and 5 for 100 times each, so that it will give you the mean of all the arms, right? So how many times you need to play now? You need to play 500 times. You have to pay and play 500 times, 100 times each arm, in order to find the mean for all the 5 arms. From that, you can come to the conclusion that arm 3 has highest mean, isn't it? That is what I am explaining here. So for example, if a slot machine has 5 arms and you are playing only 10 times, then you need to play 50 times to find the best arm. But is it really possible or practically possible, or is it the feasible solution in order to find it? Because for example, if the slot machine has m number of arms, which is 100, and you are playing, you need to play 1,000 trials, then imagine you have to play 100,000 times to find the best arm. That is practically not at all possible. So I said that we are going to discuss about learning automata, but in between that, so far what I discussed now, I talked about machine learning, we talked about YouTube, we talked about Amazon, we talked about how our data is being stealed, and all these things we discussed. Then I talked about the probability and also a gambling game also. So these are all the backgrounds which we really need in order to understand what is learning automata. The learning automata is a concept which is introduced by Setlin in 1960. Then later it was introduced or published by Narendra and Tatachar in 1974. Again, if you have a look at this one, this is what I presented some times ago in my presentation. A learning automaton is an adaptive decision-making unit situated in a random environment that learns the optimal actions through repeated interactions with its environment. So what it will do, it will take a decision and find the optimal solution by repeatedly interacting with the situation. So one of the simple example which I can say about learning automata is that you are standing in a place that now you simply imagine that you are standing in a place with a ball in your hand, and you are throwing the ball on the wall. Repeatedly you are throwing the ball on the wall and your objective is to catch the ball. So if you are real expert, then you can throw the ball and catch it exactly. But what you will do, by doing that repeatedly for several number of times, you will learn and understand in what speed, at what height you need to throw the ball so that the ball will come to your hand at this speed at a particular position, isn't it? How do we learn that? Because every time when you throw a ball onto the wall, the ball is coming back to you. So what you are doing is an action to the environment and it is giving you a response, right? The response is the way how the ball is returning. You store the data, then based on the data, you alter the data in such a way to throw the ball again to the wall so that you can receive the ball in your hand in a particular position. So you are doing it repeatedly in such a way in order to learn. So ultimately at one point of time, you will do it very lavishly by throwing the ball onto the wall and catching the ball. Or you might have seen that a person playing with three balls on his hand, right? They are throwing one after each other and catching all the balls in a sequence. How does he do that? If we go and try from the first attempt, we will miserably fail. But if you are going to practice this over a period of time, we may also able to do that. These are the simple examples from which are these are the some typical examples which give how do we learn from experience. That is what learning automata is also doing. Learning automata also typically learn everything from experience. So learning automata select their current action based on past experience from the experiment environment. Let's see how. This is what I said. Every time you send an action, the environment will give you a response. Learning automata will store the response. It will send another action, receive the response. By repeatedly doing this, it will learn what is the optimal action to be taken in order to get an optimal response from the system.
Sir, you're muted.
No, I intentionally muted for a while to make sure that everyone is following me. It's not that simple, learning from experience, right? Let's continue. So LA selects one random action from the set of actions and send it to the environment. That's what I said. Every time when it sends a response to every time when it sends an action, it will receive a response. So the response will be stored by the environment and further it will process it. So what it is doing, by repeatedly taking random actions and receiving random reward corresponding to each action, the learning automata learns to find optimal action which provide best reward in an expected sense. So the last word is very important. I will give you another example. Let's say that you are, you are working at a particular place, or you want to travel from one place to another place. It can be you can select your source and destination, that you want to go from your home to your workplace. Both are new to you, right? You just moved to a new home and you are starting your work, or you got a job you want to go to a new working place from your home. So what you will do on the very first day, what you will choose? How you will reach your office, because you really don't know where is your office and you want to ride your car, right? Consider that you want to go to your office in your car and you are not really sure about where your office is because it is a new place. So what you will do in order to find your location? How will you drive your car to your office? Any answer? Certainly. So if it is me, then what I will do is I will select Google Map, I will give the destination and I will follow my Google Map. But over a period of time, we will stop relying on the Google Map, right? Or after 1 or 2 days, we will stop relying on Google Map and we will go by ourselves. But we will not stop with that. What we will do, then slowly we will try to discover new routes to go to the office, right? Slowly we will try new routes to go to the office. So what I will do, once in a week, I will try to go through another route. My friend may say, "Oh, you are coming through this way every day. This is very traffic, man. Why you are preferring this route? There is one shortcut. If you take that route, you can skip some of the uh, some of the signals and you can easily reach your office." Then what we will do? Next day, we will start bit early and we will try to find out that route. We will go through that route one day. But again, the very next day, probably we may not go through the same route, or the next day also we may go in the same route. But again, you will prefer more to use the own route which you have been used up with. In between that, someone else is suggesting you route number 3. What you will do? You will give a try to route number 3 also. So, if there are 5 different routes to go to your office from your home, what you will do is, from the beginning, you will follow a route, but you will try other routes in between quite often, but not every time. Then, by going through all these routes, at the end of the day, what you will do? I mean, over after a period of time, you will come to the conclusion that this route has this problem, this route has this problem, this route has this benefits, and this route, if I follow this route, this will be good. Then, after analyzing all these things, you will take a decision and you will say, this is the best route to go. Then you will repeatedly go only through that route. That is exactly what learning automata is doing. Let's see with an example how that learning automata works. So learning automata or LA algorithms are algorithms that can be used to learn the best decision making in a single stage decision making problem. Right, that is another thing. Because here the examples which I have mentioned to you now, all the examples, whether throwing a ball on the wall or going to your office from your home, whatever is the example, they are all single stage decision making problem. You have only one decision to take. If I start from here and reach there, which one is my best route? That is what I want to know based on our own constraints, based on the constraints. So LA algorithm is suitable for taking single stage decision making problems. How LA work? So we already have seen how this Enam Bandit problem works. In Enam Bandit problem, what was the problem? If you want to find the best arm, then you have to play n number of times the m number of arms in order to find which one is the arm which is having highest mean. Here, our objective is not to find the mean of all the arms. Our objective is only to find the best arm, right? Our objective is only to find the best arm. That is why I just explained that example. LA algorithm plays the arms that are likely to be the best more times, right? So every time when I told you that I learned learning automata from Imtiaz sir. So every time Imtiaz sir give an example of going to a hotel, going to a restaurant to try food. So we will go I mean, if you are new to a place, then based on the general observation you receive from your friends, you will go to a restaurant by considering that the restaurant is serving best food, tasty food. Then over a period of time, what you will say that I want to try another restaurant. So you will go to another restaurant often, but you will not select the another restaurant every time. In between, sometimes you try but you will stay with the restaurant where you feel that it is good. But by going around all the restaurants, finally, by repeatedly doing that, you will find that there is another restaurant which is much better than that of the restaurant where you are going. And you start going there. So LA algorithm plays the arms that are likely to be the best more times. Let's see how it work on this one now. So what it will do, it is using pursuit algorithm in order to find the best action. So it is selecting the estimate or mean of all the arms to be equal to 0, and the probability is also 1 over n. I just want to skip this part because I will just go through this one quickly and I will go to a main part. So let us consider that the machine has n number of arms. A is equal to 1 to 5. Therefore, the uniform distribution is 1 over 5, 1 over 5 for 5 times, which is 0.2. I initially selected the estimation because I don't know what is the mean of the arms. So I put 0 as a mean for all arms. Now, for in each iteration, what I will do, I will play one arm. When I play an arm, it will give me a random reward. Based on that reward, I will update the estimate of the arm which I played. So, when I increase the estimate of the particular arm I played, I will decrease the estimate of other arms. That is what these equations are doing. But like explaining these equations is not advisable at the moment, I feel. But anyway, let's have a look at it. What it is doing, it is going to increase the probability of the arm by greedy. It is taking a term, but for all the other cases, it will decrease the probability of the other arms. I will show that with an example so that you can easily understand. I am playing arm number 2. Arm number 2 is here. And I receive the reward 90 while playing arm number 2. Next, what I will do, I will update the mean of this arm now. So this is the first time I played. I set the mean of all the arms as 90. Since I played only one time and I got a reward of 90, I am updating the reward of only that mean value. So now, what is the best arm according to my understanding? I played only once arm number 2. I got a reward of 90 and I updated the mean value of all the arms. Based on the present situation, best arm is arm number 2. Best arm is arm number 2. So what I am doing, I already know that since there are 5 arms, therefore the PDF is 0.2. So with a certain value of beta, I am increasing the probability of this arm. So the arm value become 0.6 now when beta is equal to 0.5. I will tell you why I am giving stress on this beta now. When beta is because here we have like 0.2. I am just using by like 0.2, 0.2, and 0.2. So what happens when I use beta as 0.5? This value will become 0.6 now. This value will become 0.6. So I have taken the remaining 0.4 from all the other arms. Therefore, this will automatically become 0.1 0.1, 0.1 and 0.1, because when you add them, ultimately the answer should be 1 in all cases. But instead of using beta is equal to 0.5, if I use beta is equal to 0.1, then this value will become 0.28. This value will become 0.28. This 0.08 is taken from all the other arms. So this arm will become 0.18 for all the other arms. Right. What is the advantage of doing this one? Let's see. So this is equal distribution at the beginning. When I played, what happened? For arm 2, it became 0.6, and for all the other arms, it became 0.1. And when I am using the probability of when I am using beta is equal to 0.1, it is giving some values like, but what is the, what is the purpose of selecting smaller value? We always need to select smaller value for beta. Otherwise, in few iterations, it will find one arm by attaining the maximum value, but it need not to be the correct solution or optimal solution, because we didn't play enough number of times. So that is why we are selecting that particular value. Now, as the iteration increases, the probability of best action selection increases and the rest decreases proportional to beta. Now, if you have a look at this one, so I explained this one. I played arm 3. I got this one. So I updated these values now. By repeatedly playing, what you will do is every time it will adjust. For example, when you play arm 3 second time, and if it is giving you a reward of 100, for example, this arm 4 value will become 100 now. When this becomes 100, what is the greedy arm? Now greedy arm is arm 4. So now it will increase the value of arm 4 and decrease the value of all the other arms. By repeatedly doing this, it will finally identify which one is the best arm actually. So learning automata do the process for several number of time based on the number of iteration we give, and finally it will automatically terminate with the condition that, let us say that our condition is 0.99, because as I said, it is PDF uniformly distributed. Therefore, the total value will be always 1. So when it is reaching 0.99, all the other values are much smaller, which means this gives that this arm is the best arm. How do we confirm that? Based on the values which I have given here, if you have a look at it, this arm is having highest mean. Since this arm is having the highest mean value, this is the best arm to play, because this will give you the best reward, right? So if you play 1,000 number of times, then the average or the mean estimated reward which you are going to get from this arm is $90. This will give you $85. This will give you $90. This will give you $80. But when you play arm number 3, the mean reward which you are going to get is $95. So learning automata is applied in several applications like the ATM switch function, or mainly in the communication systems. But at the same time, it is also used in power systems, where learning automata is mainly used in load scheduling problems. And I used learning automata for the purpose of developing a maximum power point tracking controller for a solar PV system, which I will show in the next 2-3 slides, right? So in order to understand how we are using this learning automata for MBPT algorithm, we need to know how the solar PV system work and what is its basic characteristics. This is the PV characteristics of solar PV system, where the output power is maximum at only 1 point at any instant of the input. So whenever there is a change in the temperature or the light intensity, the operating point of solar PV system also will vary, and the maximum power point will also vary like this. So as it is varying, we need to adjust the operation of the converter in such a way to operate the system at maximum power point. We always need to change the operating point in order to maintain it in the operating point. So what is the objective here? To find the maximum power point. And since the objective is only to find the best duty cycle here for any instant, the problem is also treated as a single stage decision making problem here. So if you have a look at this one, it is necessary to change the operating point of the converter to match the load resistance so that maximum power can be obtained. How we are doing this? I'll show you here. So when we are using the conventional MBPT algorithm, the conventional MBPT algorithm will also reach MBP. But once it is reaching MBP, then it will oscillate at the maximum power point. Those who are working on solar PV research may be able to understand it in a better way. So as long as there is a variation in the inputs, the duty cycle of the converter will also vary from one point to another. Again, it is not stable at any point. So in order to obtain that one, we are using learning automata as MBPT here. As I mentioned before, the objective is to find the best duty cycle among the set of duty cycles at which it will give the maximum power. So we are using learning automata here because the problem can be treated as single stage decision making problem. In order to do that, the total temperature and irradiation range is divided into zones, and we have given set of duty cycles. Let me go to that one. I said that if for every action to the environment, learning automata will, environment will give you a response. That response will be stored by learning automata to take the best decision. Here, what we are doing is we are giving input to the solar PV system. Solar PV system will give one output based on the duty cycle which you are giving here. So duty cycle is the action. This is the environment. Whenever you are setting a duty cycle, the environment will give you output power. That output power is stored by this learning automata and it will optimize the solution. So for a particular zone which I have selected here, I am just giving a simple example here. I have selected 8 zones. If you have a look at this one, I have selected 8 zones. 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, and 2, 4. I am giving some random duty cycles for zone 2, which is having 10 number of duty cycles. So what learning automata will do is, it will send all the 10 duty cycles randomly for many number of times. And finally, this will find the optimum duty cycle. So according to this one, initially, it was considering that duty cycle number 7 is the best duty cycle. Then later it realized that duty cycle number 8 is the best duty cycle and it converts to the solution that this is the best duty cycle. In this way, we found the duty cycle. Yeah, let me go to this one. We found the duty cycle for the large range of environment for different input conditions, and that is been applied to in order to save the results. Then finally, the results are stored in an environment. So what will happen is finally, whenever similar situation occurs, learning automata know what is the actual duty cycle and it gives the duty cycle back as a solution. So the learning automata MBPT is finally applied to the solar PV system where we used different input conditions. This is the conventional MBPT, how it is working, and this is how the learning automata work and give the optimal duty cycle. So that's all about how the learning automata is being applied for developing a particular engineering application, which is MBPT algorithm in my case, and you can use this for any applications which are considered to be a single stage decision making problem. Here are some of the useful links, and this is how it goes actually. So I learned learning automata from Imtiaz sir, and the network goes here to Shastri sir, then to Professor Dattachar, then Dattachar to Professor Narendra, and the cycle goes on. So this is the book every time for Dr. Imtiaz referred for anyone who want to learn reinforcement learning to read. Sutton and Bartos, reinforcement learning. So with these things, I am done with my presentation for this session. If you have any questions, you can ask me now. I think probably no. So thank you everyone for your patient listening for last 2 hours. And as I like I mentioned it a couple of times that learning machine learning or learning automata in the afternoon after lunch, especially through online, is not not a feasible thing, but we have no other go. So I just shared my experience and knowledge on how learning automata works for different engineering applications. You can take it further to any level to apply learning automata for any engineering applications where the problem is a single stage decision making problem. Thank you. Thanks to all.
Any questions from audience? Okay, fine. So thank you, Dr.
So,
Sheikh, for selecting.
asking them to ask question is now a great harm actually. We are sitting for a session for 2 hours is a great thing, I feel, right?
Exactly. So thank you, Dr. Sheikh, for selecting and delivering a key topic, which is related to FDP on embedded systems and machine learning for engineering application. Actually, he inspired us during afternoon through interactive questions and answers to teach the basic background of collecting data through internet usages, applications, and apps. He also inspired us by explaining head and tail probability problems given by his guide, Dr. Imtiaz Ahmad, to teach learning automata during his PhD work. And finally, he concluded the things which he got during by means of learning automata, how he applied that in his PhD work. Sir, your section were very informative, and I hope all participants got the concept of learning automation in a clear manner. Once again, thank you, sir, for giving a wonderful informative session on learning automata. Thank you, sir. As a part of appreciation towards the presentation titled Learning Automata, here we are presenting a virtual memento for Dr. Sheikh Muhammad Sultan.
Okay, thank you, Dr. Mansoor. Thank you for the opportunity and the initiatives you have taken to collaborate with UTB. We have one more session from Dr. Ahmed Azlan on Wednesday. And thank you for the wonderful virtual memento.
Thank you, sir.
Thank you. Okay, thanks to all. Assalamu alaikum. Take care, stay safe. See you again in some other interesting sessions.
Okay, sir.
Bye.
So today FTP section is completed. Thank you all for joining for this FDP. Tomorrow and day after tomorrow, the session will start exactly from 9:30 a.m. And coming 2 days, we can have offline section on power electronics converters, its controller design and hardware implementations, simulations, etc. For offline participants, it is possible to get hands-on experience in implementations of open loop and closed loop controller programming in embedded system perspectives. All these events are available in Zoom platform too, with same link shared earlier. Thank you all once again. Hoping you're timely joining to the each and every upcoming sessions. Thank you all.